Hello and welcome. In this tutorial, we are going to focus on modeling a wireless sensor network with Python. So you might be asking, what is a wireless sensor network? A wireless sensor network are a bunch of nodes connected to each other, sending their data node to the base station. We are going to model this system with Python. The assumption here is that you have a basic understanding on the wireless sensor network operation and also a basic knowledge of Python programming. So this literature will not focus on any kind of literature review or any kind of definitions as well. To model our sensor network, we are going to use a book and all the code that I'm going to implement within this tutorial will come from this book. This book is located at the store of Class Creative, and essentially you could go and get a copy and play around with the code as well. We are going to use a platform to model our wireless sensor network that will be located at the projects, and it will be this application over here, and this will be the application that will be used, or the platform that will be used to model our sensor network. I am going to do copy and paste over here, so I'm essentially taking the code from the book to model our system step by step. Okay. To model our wireless sensor network, we could break it down into different components. So we are going to call each model, each component, a node. Okay. So the first component we're looking for are the parameters of the simulation. Okay. We also are looking for the sensor node model and also the energy model of the sensor node. So these are the different components that we are going to focus on for now. Let's start off with the first node, which will be the global parameters and the packages needed to proceed with our simulation. I am going to copy and paste here. So what we need right now are the following. We need those packages. Paste it here. Okay. We need math package. We need NumPy and a login system, and also matplotlib as well, so that we could see our visuals as well. We need a global parameters, and this is the global parameters of the wireless sensor networks. Now, basically, this is coming from literature. Okay, you could verify this for yourself. Essentially, we want the number of nodes, the transmission range, the dimensions of the region of interest, the maximum rounds, and the base station ID as -1, which will indicate that among all the 10 nodes, we want the last node to be the base station. The position of that base station, we want it to be 250 by 250. You could change this and put your own. The message length, we want it to be around 4,000 bits, header length 150, and the initial energy for the nodes, not the base station, is 2 joules. The following parameters that we need as well the following. We need this for the wireless sensor network to operate correctly. Now, this is coming from literature. So the assumption is that you know what this is, but essentially these are the energy dissipated within the amplifier due to multipath and due to free space. Okay, this is all proven within literature of the wireless sensor network. We're also going to define a log as well, so that when we print out once we print out our execution, we'll be able to see what is happening within the simulation. Okay, so these are the global parameters that will be needed, and also the packages that will be needed for our modeling with Python. Okay, so we are going to submit that model and close that. So that will be the first node. The second node, which will be node 1, will be the model of the sensor node itself. Now, the sensor node does come is an important component of the wireless sensor network, and it does come with different attributes such as amount sensed, amount transmitted, the next hop, which will all have to be defined as methods and attributes within a class of node. I think for this part, I am going to type this step by step so that it will be a basic understanding. But let's define our node as a class, or sensor node as a class object. Okay, and let's define the init method first, and it's going to take an attribute of ID and parent as none. Okay, so within this initial method, we are going to define the position of the node. Position x. Okay, so we assume that the nodes are placed randomly within the area of interest. And that'll be also the same for position y. So random. Let's define that if the ID is the base station ID, we want the energy model to be different. So we want energy model, energy source to be, let's say, plugged in. Okay. And else we can say that if it's not the base station, then we could say that the energy source will be a battery. Okay. Which we're going to define later. Let's define the ID as ID. Define a network handler. That's the parent of the node. And let's define a reactivate method so that we can reset the whole simulation when we want to. Okay. And let's go ahead and define that reactivate method. So reactivate, and that would be self. And what we want to reset is whether the node is alive. The transmission queue size equals 0. The next hop should equal the base station ID. Okay, essentially that's the destination, the final destination of communication, and the distance to the endpoint equals to 0. And let us define the amount sensed equals to 0. The amount transmitted to 0, and also what else? Let's define the amount received. Goes to 0 as well, and that should be okay. Let's define now an aggregation method. Function that would equal lambda function, and also time of death as well be of interest as well, or time of death of the sensor node equal infinity for now. What else? Within the sensor node, let's also define battery depletion. That would be a good one. Yeah. Battery depletion, battery itself. The attributes associated with that will be, let's have whether the node is alive or not. And time of death will be of interest as well. So, handler, let that be round. And what else? Okay, self handler. That's equals to. Essentially, this will give us a sequential a visual of how many nodes are dying. What else? I think that should be okay. Let's define the next hop method within the sensor node. So we're going to define that as a property. And next hop. This will also be a self. Self value hop. That should be it. Let that be the value. Now the next hop does imply that we need to calculate the distance from node to node. So let's put calculate distance function here, which we're going to define later. That'll be from self and the parent node as well. So that'll be network handler value. Okay. And let's define the distance to the endpoint as equals to distance. Okay. That should be okay to define the next hop. What else? Let's define the nodes that are going to be active or alive. So let's say only active nodes within the system, and this will be a function. Let's define a wrapper here. So we're going to take all arguments for this one. Should be okay. And let's say that if the node is alive, we want a function to be executed. So our function will take all arguments. Okay. return else node is dead, so we return 0. Okay, so let's return that wrapper. So that should be it for our active nodes. Let's define another method that for only active nodes, okay, we want the following. We want to sense, we want a sense method, so that we can sense the data, and we want this to be text size that will equal the message length communication, and so amount sensed equal equal message length incrementally. Okay. Additionally, also for only alive nodes, let's have another one. Let's have transmission method. A good one. Not very important. So, transmit method. That will be self. So yeah, let's have the message length. Let's have the message length as none. And destination is none as well. Right. That should be it. So let's define this transmit method, and we're going to let's put a login system here so that we know what's happening. So let's log in debug, and we can say is when the node is transmitting, we want to know that. In fact, the node ID that is alive that is transmitting. So let's say that if nothing is being transmitted, message length, we say message length is just equal to the queue size. Otherwise, message length is equals to an addition of with the header length. Okay. Now, if the node is not the destination node, so essentially we want to transmit it to the base station, we could say destination equals self. And the distance will be self distance to the endpoint. Okay. What else? So if that's not the destination, so what else? So if that's not the destination, we could say that the distance will be the calculation distance from the node. If all goes well, then we could say, okay, the energy that's been dissipated from the sensor node is the energy from the amplifier. If distance is greater than, let's say, the threshold distance, okay, then we could do communication. Okay. Say energy, energy plus equals energy for multipath times distance to the power 4. Okay. So this is coming from literature, and else energy from free space. Okay, so what we're saying here is that if the distance is less than the threshold distance, or it has, in other words, is within range, then we could perform. Then the energy that's been dissipated within the node will be free space. If it's greater than the threshold distance, then to be multipath, the energy that will be dissipated will be multipath energy. Okay. So from here we could say transmit energy. Then we could now define the energy dissipated. Message length and the destination receive, which we're going to define. Okay, so you want to now define the received package or the receive method once the node has transmitted, which we're going to say message length. So size equals to 0. The amount transmitted equals to message length. So which we're going to define energy source consume So this is only for active nodes. Another method we want to define for only active nodes are the receive method as well. So let's see, let's define receive method, and that will be self let's see what's happening in the system. So debug. You could say that the following node has received information from the other node, the corresponding node. So receiving data from, say, okay. So that should be good. Let's define an aggregation method. So once the data has been sent, and received, we want to combine all data. So okay, that should be okay. Amount received will be plus equals and the energy for, for receiving that message length will be equal to times message. Okay, and so once we have received, we want to consume energy. Okay. Another function that we like to define for only active nodes would be the aggregate method as well. So let's do that. Let's also see what's happening within that method. Just going to copy and paste this one. Okay. And we are going to say that node, certain node is aggregating. Okay. Okay. Actually, okay. And the application cost function, we're going to define self application function, which we're going to define later. Okay, and what else? So let's size, cost, energy consumed because of that equal times the application cost. Okay. And so source consume. Okay, so that's also the method for aggregation and the energy consumed while aggregation is taking place within the sensor node. Okay, that should be it for now. Okay, this should be our model for our sensor node, which we could add some more. This could be a very complex node, but I think for now let's just leave the basic functionalities as this. So we're going to submit this model, and that should be our sensor node modeled. For the last node over here, we are going to implement certain functions to make our simulation work. For this part, I am just going to copy and paste. But we do need the energy model for the sensor node. Um, let's define that as the following. Copy paste that. Okay. So we are going to define the energy source for the sensor network as battery and plugged in. Battery is for a sensor node that is not a base station. So in other words, if the sensor node is not a base station, then the energy has been depleted bit by bit. then if the energy source is plugged in, such as the base station, nothing happens. Okay, so this will be the energy model for our sensor network. Okay, we are going to submit that, and and that should be it for now. Now let's compile everything. Um, so let's compile. Let's click this button here and see what our code gives us. Oh, not that one. This one. Okay, and this will give us the code that we've just modeled. To run our simulation, okay, to run our simulation, we do need to add some certain functionalities. We do need to calculate the distance, and we also need navigation function as well, which I also defined over here. Okay, so I am going to um, have another node for that one. So I'm just going to click here, node, and within this, I'm going to copy and paste the calculate distance and aggregation function, and basically this is the methods that are needed, well, the function that are needed to calculate the distance and the aggregation function here as well. Okay, so let's submit this. Okay, and we should be able to be okay. Let's compile. Okay, and that function should be okay. So now to run the program and see where we are so far, let's come over here and define run program. Okay. And to test this out, to test our sensor node, let's find, let's go back to the node model that I had over here. And for this, what I want to see, for example, let's take a look. Let's take a look. I do want to know the position of the node. Exactly. Okay. So let's say the position of the x-axis. I'd like to know that. I would like to know the position of the y-axis. Okay. I would like to know whether this node is plugged in or is a battery. Okay, that should be fine. So let's run our program over here. Okay. So to run our program, what we're going to do, is let's go over here if let's define this. We want to run this program. Okay. Let's take a look at what this model gives us. So let's click this red button here. Okay, it's giving us missing a required ID. Yeah, okay, sorry. Let me look for node 1, for example. Okay. Okay, perfect. So this is the position of the X position of node 1, the Y position of node 1, and is a battery. Let me look at the last position, the last node. Okay. Yep. So this is the position of our base station, and also is plugged in. Okay. So this code is working for now. So this has modeled the sensor node for now, with its basic methods. We are going to now focus on modeling the network and the routing algorithm of the wireless sensing network next time. But for now, this should do. You could play around with this. You could add what I can say next. We have 20 nodes here. See what, say for example, node 10 looks like. Okay, okay, and that's the exposition of node 10, and there's also battery as well. Perfect. Okay. Well, thank you, and I should be able to see you on the next videos on the routing and modeling of the sensor network. Cheers.